Hello class, we meet again here for the new year 2021 and you are now in Form 5. Congratulations. And we'll start our first lesson in Form 5 Maths with Chapter 1, variation. So variation is one of the easiest topic in Form 5, So I hope you can learn very well for this topic. So what we will learn, variation comes from the word vary, right? Vary. That means it change. It's related to change. So our life every day is changing. Everything changes. Okay. Now let's see. What are we going to learn? There are three things that we'll learn: direct variation, inverse variation, and combined variation. But for today, we'll learn about direct variation only. Okay, are you ready? Let's go. Okay, class, direct variation. So today only two learning standards. Number one, we are going to learn about the meaning. You will be able to explain the meaning of direct variation. This is the concept, very important. And the second one is determine the relation, the relation between two variables for a direct variations. Okay. Okay, let's see the meaning. The meaning of direct variation. Let's say you are a cook. You help your mom. You cook 5 rice, five cup of rice for 10 serving, I mean for 10 people lah. So if suddenly it become the people increase, let's say your relatives come from the kampung, 20% coming to your house. So how many cups of rice? Of course, you see, this one is already double, times 2. Of course, your cup of rice also will be times 2. So it will be 10 cups. Okay? So that's the meaning of, that's explain the direct variation. In our daily life, we often face situation that involves relation of quantity changes. Quantity changes. For example, this one lah, quantity, the cup, and also the serving or the people. And there are many more in our daily life, that things that changes in many variables. Okay, direct variation explains the relation between two variables. Always two variables, such that when variable y increase, variable y increase, then variable x also increase at the same rate. This is very important, at the same rate. Okay, what is the rate? Okay, let's see. If y increase, let's say y increase 2 times. 2 times. So this will become 2y. Then x also will increase 2 times. So this will become 2x. So 2x is the rate. The same rate. The change in y and also in x, and vice versa. That means if y decrease, x also decrease with the same rate. Remember, and this relation can be written as y varies directly as x. If this happen when y increase, x increase with the same rate, we can say y varies directly as x. Okay. Let's see some example. Let's see some example. The total wage. So this is one variable, right? Of a part-time worker as a promoter varies directly as, the number of hours, the number of hours. So this is another variable. So if you want it to be in a letter form, let's say this is total wage will be W lah. So hours will be H. So that is the two variable, W and H. State the change on the total wage. That means what is the wage if the number of working hours is double. Okay, when the hour, this one is double, that means your what? Your total wage also will be double lah. So the total wage is also double if the hours double. You see, that is direct variation. Okay, if the total wage, state the change on the total wage. Okay, total wage if the number of working hours is decreased. Hours is decreased into 40%. Of course, your wage also will decrease by 40%. That is the rate, 40%. Yeah. It also will be decreased by 40%. Okay, for C, state the change on the number of working hours. Okay, the number of working hours if the total wage is half. So when the total wage, this one become half, of course the number of working hours also will be half. Yeah, will be half, fair and square. If you work, when your wage is half, so your number of working hours also will be half. So that is the direct variation in this example. Okay, I hope you get it. The meaning of direct variation, it has a rate. It has a rate, certain rate that you have to follow. Okay. Okay, class. For a direct variation, y varies directly as x. If you see this term, this sentence, y varies directly as x, it can be written as this one, y alpha x. This is a relation, this is a variation relation, but you can change it into equation form. You know, you are learning maths. Maths always have this equation, the symbol of equation. You cannot solve by using this. So you have to change it in equation form. You just write equal, but there is k here times x. Okay, so what is k? K is actually a constant. It's actually a constant, and actually k is the rate. K is the rate of the change. And you can find k. Okay, class, you can find k. How do you find k? K is actually the gradient. It is actually the gradient. From this equation, you can see also k equal y over x. So if this is y, this is x, so it is actually, k is actually the gradient. Yeah. But we are not going to learn gradient today. Yeah? I just want to see to show to you. And for direct variation, another important thing that you have to remember is if you draw the graph, okay class, if you draw the graph y to x-axis, what you get, of course, it is a straight line. Why it is a straight line? Because it's a linear equation, y equal kx, right? It's a linear equation. Of course, it is a straight. It's a straight line. But the most important is it passes through the origin. Here, it must pass through the origin. Okay, why? Somebody can tell me why it must pass through the origin? You got to think about this. This is very important concept. So if the graph is like this, y, x, and it passes here, does this meaning y varies directly to x? No, no. Because when y varies directly to x, the equation is y equal kx. If you still remember in your linear equation, your linear graph, when this pass into origin, that means your mx plus c, still remember? Your c is actually 0. Yeah, no c. You don't have c in a direct variation. So it must pass through the origin lah. If this one you have c, let's see. Let's say this is 2. So your graph will be y kx plus 2. This is not a direct variation. You have this plus 2. Direct variation must be in this type of equation. So remember, it must pass through the origin, then it is a direct variation. You can say that variable y varies directly as the variable x. Okay? I hope you can grab the concept, yeah? Okay, so in general for a direct variation, y varies directly as x power n, varies directly as x power n, can be written as this one, the variation relation, y alpha x power n, and you can write in equation form y equal kx power n, and your n can be 1, 2, 3, or it's in fraction. That is the square root, right? This is the cube root. That means like y equal kx power 1 over 2, or actually it is in a form of square root. Or if it is y equal kx power 1 over 3, that means it is actually cube root of x. Okay, so direct variation can be in this form, can be in this form, so your n can be any number lah, any number. Okay, so the graph of y against x power n is a straight line, passes through the origin. Again, passes through the origin. This one, y against x power, let's say x power 2, pass over the origin, and it is a straight line where k is the gradient of the straight line, meaning k is this one, y over x square. Yeah. Okay, for this one, the graph of y against x square, and this is for example, let's say your n is 2 over here. So y against x square is a straight line that passes through the origin, this graph. So why is it straight line even though you have x square here? Because sometimes when you see this type of equation, y equal let's say 3x square, you say that this equation, the graph should be quadratic, right? Should be like this, yeah. And if y equal to x power 3, it should be like this. But why it is stated here that the graph of y against x square is a straight line? Of course, because this graph, it is a quadratic graph if the y against x, yeah, y against x, this one also, yeah, of course you'll get graph like that. But for this one, because your x-axis is x square, then you get a straight line. So don't get confused, even though you have this type of equation, yeah, mx square, and the graph is like this because of the x-axis is x power 2 and it is a straight line. Okay, example 2, a toy car moves from a state of rest. The distance traveled by the toy car, yeah, y, here, changes with time, yeah, changes with time. You can see here the time and the distance are changing, and you are asked to determine whether y varies directly as t or as t square. Which one? Yeah, y varies to directly as t or y varies directly as t square. Yeah, t square, which one? So how do you determine, yeah, whether y varies directly as t or t square? Remember, you have to find the what? You have to find the k. If the k is a constant, remember, when the k is constant, then it is a direct variation. So very easy. What you do, the graph, you write back your t and y, and then you find y over t. This is your k, yeah, this is your k. And then you get 14 over 2, 7, 28 over 4, 7 also, and then you get 7, all 7, yeah. So your k is a constant, same number all the time when you divide. But when y over t square, this is also okay, should be okay. But it is not a constant. Yeah, k is not a constant. So of course it does not vary lah. Huh? This one, no. Y actually varies directly as t. Okay, how do you write that? Y varies directly as t because the value of y over t is a constant. Hence, you can write y alpha t. Yeah, this one. And y does not vary directly as t square because y over t square is not a constant. Do you get it? Okay. Next, example 3. Yeah. By drawing the graph, how do you determine whether the two quantities varies directly? Okay. So you just check on the what? When it varies directly, it must pass through origin. This is y, this is x, must pass through origin. If this one, your graph, okay, this is y, this must be x square, must pass through origin. Then it is a direct variation. So what do? You just draw the graph. And it seems that when you draw the graph for this one, for y and x, it does not pass through the origin. It has a C here, 1, you see. So of course you can say that y does not vary directly as x. But for this graph, when you draw the y against x square, you can see here it passed through the origin. So y varies directly as x square. Very simple as that. Example 4. It is given m is 0.8, n is 0.125. Okay. Question: express m in a term of n. Yeah, m in a term of n. Should be like that. If m varies directly as n. So when this statement m varies directly as n, what you do is you write m alpha n. That is the first step you do. And then you want to express m in the term of n, right? So you write m equal, you cannot just write m equal n, you must write the k first. K n. Okay. Then this is not the answer. This is not yet the answer because you don't know. You have to find what is k, right? So the next step is you find the k. How to find the k? You are given the m. M is 0.8, n is 0.12. So what do? You substitute. Yeah, your m is 0.8 equal k. Yeah, k times 0.125. So you can find your k. Of course, your k is 0.8 over 0.125. And you will get k equal 6.4. Then what do you do with your 6.4? Yeah, you just substitute back to here. So m equal 6.4 n. So you have answered the question. M in a term of n. Okay? Okay, B, yeah. M varies directly as this is the symbol, the cube root of n. That means n, the cube root, yeah, the cube root of n. Okay, so that is the first step, yeah. Then you change into equation form. M equal to, you must have k cube root of n. Then you substitute your m and your n. Okay, your m is 0.8 equal k cube root of n. N is 0.125. Okay, so k equal 0.8 divided by cube root of 125 cube root. So you just use your calculator, you'll get k equals to 1.6. Yeah. Okay, when you get your k 1.6, what do? You substitute into here. Yeah. So m equal 1.6 cube root of n. So this is your answer. Express m in the term of n. So this is the answer. Okay.